Hi and welcome. Last time we created some roots with help of the tree component. Basically we created a tree simply growing into the opposite direction downwards. But this time we'll take another approach and we will create our roots with help of deformers. Again, I'm starting with a simple tree, and this time we have to find a way how to deform the base area of this tree with help of some deformers. So if you take a look at the components library, you can find that we have the simple object, some objects which are generating geometry, some multipliers, and down here we have two deformer objects. The patch doesn't work in our case, or probably not as good as we like it to work. We don't have that many control over the shape we want to achieve. So I'm taking a look at the attractor object in this case. To make it work, drag the attractor object into your scene graph, then drag your tree, or we could create it at this point of the hierarchy, then drag your tree hierarchy onto the attractor or FFD object so that it's a child object of this deformer object. Now you can see that nothing happened so far, and also when taking a look at the parameters of this object, you won't find many options how to deform the shape of the tree. This is because we need a second object to make it work. Therefore, take a simple object, drag it into your scene graph. I make a child of this null object because later on we can move the tree together with all the deformers in one single object. Activate the simple object. By default, the simple object is nothing more than a simple null object. But if you go to the primitive tab and change the primitive type to attractor, then we have a deformer object. Still nothing changed. But if you go to display and choose show hide attractors, then you'll notice this red sphere. And this basically shows us where our deformer is. So now you can go to the basic tab and start to move around this sphere. Therefore, I'll adjust the range of our sliders, because -50 to 50 is simply too far. Just double click those numbers and you can adjust those sliders. So now we can move the attractor. And now you might ask, why is still absolutely nothing happening except of this red sphere moving around on the screen? This is because not only the geometry which has to be deformed should be child object of the FFD, or down here it's called attractor, but also the deformer itself has to be child object of the FFD. So drag it onto the FFD and immediately you will notice the effect that it has on the geometry. I'll rename that one to Attractor 1. Okay, so now when you turn on the wireframe, you'll of course notice that there's not much geometry which can be deformed, and so the results wouldn't be very convincing. So we need to increase the resolution of our trunk object. Therefore, we'll select the tree, go for segments and increase the number of segments to probably, let's say, 80. and then go to the primitive type tab and increase the number of points to, let's say, 36, something like that. And now you have a lot more geometry which can be deformed by our attractor objects. And now it's basically up to you what you want to do, how you want the trunk to be deformed. We can move around the attractor to the desired position. We can change the scale. For example, we could increase the overall scale, but I would like to increase the scale only along the z-axis. Okay. And well, the strength is controlled with this slider right here. And then we have a kernel. If you increase this value, the deformation will get stronger and also will try to conform to the shape of the deformer. The lower this value, the smoother the deformation will be. So I'll lower this value. And now we have our first deformation. And I think it might look better if we try to rotate this deformer. So I'll switch over to the basic tab, go for rotation values, and in this case I'm rotating around the y-axis. Now you can see our deformer is leaning towards the center, and now the deformation looks a lot better in my eyes. So one thing you have to understand is that the attractor has several different options. If it's set to point, it always will try to deform the geometry from the center of the sphere, so it's always pushing outwards. It's also possible to change this to X, Y or Z. In this case it's only deforming along those specified axes, but in many cases you get the best results with the direction set to point. Now we simply have to create several deformers to create a more interesting shape. In this case I'm simply copying the first deformer. I'll rename that one to Attractor 2. Then I'll move it over to the opposite side, change the value a little bit, then also change the scaling of this object so that we get different shapes. That's probably a bit too huge, too massive. Okay. And now you could go on. I'll turn off the shading wireframe and also the display. Now you can see we have a lot more interesting shape around the base. We could, or we should, copy more attractors and place them along or around our trunk. But now I'll show you a different way how you can save a lot of time. You don't have to place every attractor on its own manually. Of course, with some you should do this simply to create some variation in your shape. But you can make use of the multiplies also. So in this case I'll use the Hydra or Red, for example. Make it child of the FFD. I'll copy one of those attractors, make it child object. Of course we need to know what's happening and where those attractors are placed, so I'm turning those on. This deformation is of course a lot too strong, but we can adjust this in a few seconds. First I'll hide the first and second attractor. You can see as soon as you hide those attractors, the deformation is turned off. So that's also an important point to keep in mind. For now I'll turn those off. Then I'll select the child attractor. We move this and rotate that one along some axis, so I'm setting this to 0. Also I'm changing the size to the default 111. And now we'll make use of the different parameters that we can find in here. First of all, we'll reduce the number to about 3 or 4. Then we can start to move the objects along the y-axis. You can see what's happening, and then we have to rotate the Hydra along. It's the y-axis again. 90 degrees, that's 1.57. And now you can see that those multiplied attractors also are able to deform the shape. So instead of placing each attractor manually by hand, you can make use of multipliers to generate many of those deformers with a few clicks. It's probably even more effective if you use the phi-ball instead of the Hydra. So I'll make the phi-ball child object of the FFD. Simply move the attractor over to the phi-ball. Now we get a huge mess, but we'll change that in a few minutes. So first of all, I'll reset the translation settings. We don't need those for the phi-ball. Then we go to the phi-ball itself, and for the beginning we change the number of child objects to 5 or 6. Now we have to limit the multiplication of those objects in the ground plane area. So we'll use the fan parameter to do so. I'm using values of 1.56 to 1.58. So now those attractors are all placed in one plane, and we can use the radius of the phi-ball to move those outwards. And now you can see we already have a nice deformation. I'll hide those attractors for a moment. So really simple and effective, and because the phi-ball arranges those attractors in a natural pattern according to the golden section, we already have a real nice and organic look of this deformation. Additionally, we can use the scale parameter to change the size so that those deformers have different size. For example, I'll turn them on for now. You can do this manually. So for example, like this. Now we have some attractors being smaller, having less effect on the geometry, some others being bigger in size, and so also having more effect on the geometry. We can increase this effect by changing the dimension of our attractor. And I think I'll also change the rotation. Should be rotation X. Yes, it's rotation X. So now you can see we have a nice deformation at the base of our tree. It's not a pure cylinder anymore, but it's a nice organic shape. And we can increase or improve the result by increasing the resolution of our trunk. For example, we could use more points along the profile, and also the number of segments could be increased. So now we have nice smooth deformation. So back to the phi ball, which is multiplying our attractor. Right now we have the cosine function for the scaling and adjust this parameter, the range of this parameter by hand. We also can make use of a random function. Therefore, change the type to custom. And right here you could enter something like 1, which would be simply the original size of our deformer, and add a random function on top of that. I'll turn on the attractors, and now you can see we can control the strength of the random effect by adjusting this slider. You can see we have some smaller, we have some bigger ones, and we could increase the number. Say we're using about 9. Turn this off, and you get a nice deformation. Simply play along with the number until you're happy with the result. You also could change this to a negative value. This could also create some interesting effects. So despite the fact that we really only have one attractor active at the moment, multiplying it with help of a random function creates a lot of variation in the deformation of the geometry. And of course you can combine this half-automatic way of deforming your geometry with the manual way. You simply turn on the manual attractors that you placed. I used the second one in this case. You can see the effect that we have right here. And now it might be interesting to move this attractor to a place and try to push the hull inwards at a certain place. So now we would have to turn on the attractors, but now everything would be very cluttered, and I think it would be hard to move this attractor exactly to the position where we would like to push the hull inwards, because we only see a red mess. Otherwise, when hiding those attractors multiplied by the phi ball, we don't know anymore where we want it to go. But there is a simple solution. For a second or for a few moments, we simply can switch back the primitive type of our manual attractor, switch to sphere. Now we can hide the other attractors. We still have the effect of the other attractors. Now we can move our sphere. I want to go it exactly right here. change the rotation a little bit. Okay, then switch back to Attractor, and now you can see how we are moving or pushing the hull of our geometry inwards. And now we can reduce the size. And now we have a nice deformation, and with a few steps created a lot more variation in our shape. We could do the same with the other attractor. Unhide, by default it's over here. I want to change to a sphere for a few seconds, then move it over here, change the rotation. Okay, and now switch the primitive type back to Attractor. You can see we are pressing the hull inwards at this position. And now we can change the scaling of our primitive. And simply move your object around until you have the desired effect. So that's a little bit too strong. So I'll simply go back to strength and reduce this effect. So this second method of creating root-like system or root-like base makes use of deformers. Keep in mind there are some pitfalls when using those deformers. First of all, to be able to see them, you need to turn them on in the display menu. It's turned off by default. Second, be sure that the deformed geometry is a child object of the FFD, which is basically the attractor. That's also a little pitfall. In the components library it's called Attractor. As soon as you have it in your hierarchy it's called FFD. And then you need simple objects. Switch the primitive type to Attractor, and then you can start to move those simple objects around and deform your geometry. Be sure that both the deformers and the geometry is a child object of the FFD. Next time we'll take a different approach. There's a third way you can use to create root systems for your tree objects. So I think for now that's all I have to say about attractors and deformers. See you later with the next video.